Good morning, and thank you very much, organizers, to give me an opportunity to speak for the conference, Fifth Digital Congress for Nanobiotechnology and Bioengineering. Today, I am going to present my work, which we published last years on the topic on-site visual detection of heavy metal contaminated using impregnated strips. Myself, Dr. Imran Uddin, presently I am working in as a senior research scientist in Nanolab, University of Hungary, aka University of Pannonia in Hungary. So we will start our topics. Actually, basically, I am from India. So before we started my work, exactly related to heavy metal contaminations, how its impact to other things, I just give a glimpse of some photograph which is very famous in India, then how we'll try to correlate with my research work. So directly we have to come to the point. This is the seven wonder of the world, and you can say that this is one of the seven wonder in the world, which is very famous. Everybody know about this is Taj Mahal, and it's so beautiful buildings. If we see the another drawn view of this building, see, so how beautiful is looking it. You can see the Taj Mahal, the nearby some there is some more buildings are there, and the beauty of that building is that is place in front of or in beside the River, which is very famous in India, which is known as Yamuna. So the Ramuna rivers and all this. This is the reality of. But if you go there and really try to see this place, so the reality is little bit different from there. Go this part. So beside this river, can you see this? Can you see this? There is a lot of dust is there, a lot of garbage is there, a lot of contamination is there. And government are planning to remove so much from there. Okay. Now we have to go some other part of India. There is a very famous place which is known as Varanasi. There, and this is very holy place, and this is a photograph like from the photographer. They check there is a lot of contaminations, and the contamination not because of only the household, but contamination from different industries. See that there is another look that the water, contaminated water comes from industry and mixing there. And there is another look. So contaminated water is going to there and going to mix with this. Understand my point? So this is a bad scenario. You see that of the form, lot of this. So what I'm trying to explain it. So this is not this is just give an example of India is very beautiful in another way. Don't take in another way this is seriously that everywhere is like that. But this problem is still in persisting in the Europe also, existing USA also. Okay, a lot of industrialization, lot of we are mixing dirty things inside the water. So not dirty things like only a garbage, but we are also mixing. You can say that lot of heavy metal contaminations. I am just directly launched to our topic. See, if you see that in the if what water we are drinking from this, I know there is a lot of filters are present, but there is a lot of heavy metal always contaminated there. So you can see the cobalt is there, lead is there, mercury is there, manganese is there, iron is there, zinc is there, a lot of things. Here we go, and this is also somehow some little bit higher concentration. These are uh, so much you can say that is too much contaminated. So and it is very very harmful for the body, and they create a lot of disease. Just give you some simple example, like if you the contamination of mercury in your water, you can say there is a disease which is minimaticity. This is very common in 90s and 80s there, and there is a, you can see the deformation of legs, and there is some type one more disease, pink disease, which is also very common there, just only because of mercury. And if we take one more example, yeah, like this is a copper actually. This is so in case of copper also, if you see that there is again there is a disease comes which is known as minimator disease. This is arise in sorry, not a minimator. This is eye brown eyes disease, and there is a disease in lungs, and then like whole body is like contaminated. I'm giving this just example of this. So idea is to that how we can control in other way. If we cannot control, at least we can detect in which water, which what water we are drinking, what water we are using, whether it is contaminated or not contaminated, or particular metals. So at least so can we have some type of material or some type of experiment or some type of accessories, or we can say some type of equipment which is should be a very very cheap. So as a research scholar, as a scientist in my mind, I always should have what I have to design. So if we go to, if I am a research scholar, what I can design it. So my method should be not energy energy consuming. Like, this is the energy crisis everywhere. So we should not lose a lot of energy from there. Our method should be a green, not so chemically toxic. It means if you are using some material methods which already in you can say that using a lot of chemicals sort of things, and again, so we are not trying to clean some climate or environment, but still we are what we are going to do it, we are going to just spoil this with using our excrement. Should not be polluted. And this should be a cheap little funds crisis everywhere. There's a fund crisis, whether it's in India, whether it's Europe. Always there is no funds, there is no funds, so we should not invest a lot of money on this. Should be very easy to handle. Definitely it cannot be have a lot of manpower, or maybe a lot of expertise. We should act layman, like I just want to try to say that some layman can use this. And definitely toxicity should not explosive, not a toxic, not and then easy to handle. Just like in a uneducated guys, which can we cannot know, we would don't know about the science, can handle this. Like any auto rickshaw driver, any bus driver can use this. Any small farmer can use this. It should be easy to handle. And definitely, this is experimental work. We always try to cover in my research. That should not be high temperature, high pressure. It means not sophisticated. So this should be in our idea mind. This should always in our mind how we can develop such type of technique to detect some metal ion contamination for this. So consider this. We have to come to directly to our topics. Okay, how we can detect the some type of heavy metals uh, contamination using small chips, small paper strips. So in the market, if you go to detection of heavy metal, there is equipment is there. I am not doing new things. There is a absorption, atomic absorption spectroscopy, ICP-MS, UV. There is a small instrument. I just give you an example. Some more instrument are there, but this to maintain this instrument is very very tough. It is very very tough. It is not so easy. You need the expert of researcher. You need all this. How if somebody have a metal contamination, mm, his well, or maybe he's in a nearby river, or maybe some type of village, how this instrument can be maintained. These guy doesn't know about this. So I try to manage something which should be easy. Like there is a demerit. So these instruments are sophisticated. This instrument at a high cost. This have a time consuming. We need pre-treatment step. Portability, we cannot move everywhere. Like we cannot keep something in the pocket, or cannot keep in pocket and go like that. Or night highly skilled. So in our mind, we should have naked eyes. No need. Just take it from your eyes. You can detect it. It should be instrument free. No instrument needed. Before synthesizing, maybe it is needed, and it should be on site. That was my idea. I try to start this preliminary work and we publish it, and our lab is continue this thing to design much more. So our idea, we try to synthesize some type of paper strip, and which is coated with some type of CDS quantum dot. And the beauty of this, when you dip this strip into some solution which have a heavy metal of mercury or maybe copper, he can detect it. So we have to go directly to our experiment, and we try to solve this very fast, and we just try to explain you how we make it. Just go. So what we did in our synthesis method, we try to synthesize one cadmium sulfide quantum dot, and the method which we use it is we use as a starch as a solution, because the starch is biocompatible. Is give the it give the yeah, it's no coating. You can say it is a stabilizing agent also, and you can somewhat a reducing agent also. So this is the method we use. Previously, from same method, we also synthesize some more quantum dots and more sulfide nanoparticles, metal sulfide nanoparticles. So we synthesize, we take a solution of starch, we heat it, we make a solution of starch, we heat it around 6 to 70 degrees to dissolve completely starch into a water. It is all in the water, no other chemical issues. And this starch solution we divide into two part, and one part we add cadmium chloride, another part we add sodium sulfide, and we again mix both of them at particular temperature, 80-90 degrees Celsius, and keep for 5 to 7 minutes. Then we got a very clear solution of yellow color solution. So as a researcher point of view, I know that cadmium sulfide is having this size, this color is showing the photosynthesis of cadmium sulfide nanoparticles or cadmium sulfide, but we have to find out whether this cadmium sulfide or something else. So we have to go total characterization technique for this. We did a XRD, XRD for this, and after XRD, what we got it, you can see that this is well matched with the cadmium sulfide GCPS data, and the plotting of peaks saying that particle size are very, very small. For further proof that we try to do this one, we try to do a TM, and we so find out the particle size is around 9 to 10 nanometer in range. So we are from the characterization, we confirm that by this is a cadmium sulfide. There is so many other characterization technique we did. I didn't noted everything, but we try to prove that whether we are working on the same area or not, same field. Now, I say that cadmium sulfide is a quantum dot, and if there is a quantum dot, they should be show some type of fluorescence. So it should be emission there, and so we took absorption data, and this is yellow color. When it is when you excited at around 310, then we got 410 something. So we got the red emission, and it is showing the emission which whether we again we have to calculate the band gap also. When we calculate the band gap is also so like we are finalized that we are playing in the same field and we are playing in the same area is exactly correct, and we got a cadmium sulfide quantum dot with a very nice fluorescence property. Okay, now idea is to that we have to find out whether it work for the metal ion contamination or not. So this is the preliminary result which we trying to find out, and then after that we further read. We make a solution of cadmium solution. We have a solution of cadmium sulfide quantum dot and mix into a some particular with metal ion. So like we take a quantum dots in one vials, and we have to add mercury ions, cobalt ions, copper ion, magnesium ion, lead, nickel, iron, zinc, or there is some heavy metal we tried. There is some maybe some more we can try it in the next publications even we are trying. But what beauty will get when we mix with the mercury and copper, the color of this cadmium side immediately gone, and it become somewhat had a darkish brown. It is some little bit brown and black, and within second. So from this data, we were confirmed that oh, something is going on. this area. Even you can see the UV visible spectroscopy also. So we get in the region where mercury and the copper, you see the blue color. So there is a deflection which is exactly for cadmium sulfide is gone. So it means what we trying to find out that something is going on. It means the cadmium ions, cadmium sulfide, cadmium sulfide and quantum dots is going to bind with the mercury, is going to bind with copper, both of them. It means it's going to sense it. But it is like this is a colorimetric data, and we cannot say like what exactly mechanism going on. So we start with this one, and our idea is to that we have to find out in which concentration is going to bind out exactly which minimum concentration which is need to detect this. So we take in different concentration 10 to the power minus 3 micromolar, minus 2, minus 1, 10 micromolar. Okay. So in case of mercury and copper, and we mix both of them because we want to find out exactly which concentration is meant. So you can see that from the graph and data is this, understand it, this is in particular concentration, the color is going to change it. See. So this is the control one, and 10 to the higher concentration complete gone. It means all particles, so all quantum dots, CDMs is going to bind, or maybe some type of reaction is going on between mercury and is gone. But at 10 to the power 0, in 1 micromole is particular range, it is going to detect very fast, and slowly is going to down. And same thing we did for the copper, and same with the mixing. Now we try to find out that it's working for that mercury also, it working for copper also, and mixing both. But there is a value of concentration of difference. Understand my? And even we check the time, how much time it take to detect it. So this is the value for after 30 minutes. Like this is the value for 10 to the power 0 micromolar for, and then immediately then I keep for 30 minutes. So it is the reaction is going to stable or not. And again for the time. So we calculate the timing also, okay, how long it times it's going to take. Maybe after some time it is color to become dark or no things. So now the situation is that now the idea is to that because this is the big range, 10 to the power 0. We exactly not know exactly which point is going to sense it, at least which minimum concentration is going to bind it. So we have to further fractions of this part. And when we fraction this part, then further what we have to do, we check. We take mercury, copper, and mixing both, and take a 1.9, 9.8, 0.7, 0.76, and like this is micromolar concentration. And we again check with UV visible expect, and we take a mixing of this. So what we find exactly that in detection limit. So in case of mercury, if you have 10 nanomolar concentration, 10 nanomolar minimum mercury in the water, or so around 6.67 and 6.67 again for the copper, and so we can detect this. So like this is the minimum concentration that which we can detect it. So this is we confirm that this is the aromatic results, and this cadmium sulfide is can sense it. Now the again question arises, what the new in this? What is the new in this? Well, definitely cadmium sulfide have some property and they can bind it. And but how we can bring the test tube in front of some type of river? How some auto rickshaw guy or maybe some like villager can use this? He doesn't know about your science, your solution. So we have to try to make life more simple. So, but before going to this, I just tried because for publications, for research, for patent, you have to give a proof whether it's working or not working. So I have to try to give some information. I just say when cadmium sulfide is going to bind mercury, or when going to bind with copper, exactly what is going on? What exactly going on? So we predicted like a cadmium sulfide bind with mercury, and cadmium and sulfide bond somehow is going to break it, and this sulfur is going to bind with mercury, and if there is a mercuric sulfide is going to form. Same did for cadmium, and again is not showing from my photograph. So again, the copper going to bind with sulfur and some type of copper sulfide is going to form. So we have to prove this. So for end product, both of them, we try to take XRD. So this is the initial for our cadmium sulfide. In case of after reaction, we got the very nice XRD pattern for the mercury sulfide and again for copper sulfide here. So what we are going to do exactly mechanism why the color is going to change, why exactly the color is going to change. So this is type of mechanism showing it. So further, because if definitely the cadmium sulfide it fluorescence property, photoluminescence property, but you know mercury sulfide and copper is not and is going to aggregate it. So whatever I mentioned, getting emission we got from the cadmium sulfide is going to vanish or maybe and we got a clear line in this case. So in case of so this is further proof that we are losing the fluorescence property and cadmium is going to break down. Again, we have to got some FTR data and we got the signal of copper sulfide, mercury sulfide initially for cadmium sulfide. So this is to just prove that whether we are, what are exactly mechanism behind this. In the complete paper, I give some more explanation for this. If somebody interested, you can go to my publication and then we can get it. Now the question arises. Now solutions. This is the main part. So what we did, we take simple paper strip, very simple paper strip. This paper strip we just coated with our cadmium sulfide. This is paper strip, Wartman filter paper and normal paper, and we try to coat it dry for a while to remove all whatever water molecule or something is there, and we got it. And you know what is the beauty? And we try to check whether it is working or not. When this dip into a solution which is mercury and copper, you can't imagine that is immediately the color is going to change. Immediately color is going to change. We try with our lab solution, we try with our prototype, we try with some natural water and different concentration you try. So everything is in our paper, but we got. So what I'm trying to do, no, you no need to go or take your solution or need anything, just take this paper strip. And you know, so what is the cost of the formation mom making this? Just paper and this cadmium. Hardly, I don't know about in $1, maybe we get more than 50 or 40 or 50. So we are calculating a price for making a patent and all these things. It is very cheap. So no, if you want to detect that whether it is going to work or not work, so your water is contaminated or not contaminated. So for layman, for farmer, you no need to make anything like equipment or instrument. Just give this a strip, they dip it, and they find out. So this is the end project, and we are trying to patent of this, and we are getting much more result. We trying to convert this data in next publications for in digital form. How we can convert these color changes in the digital form, and so and you know how much the color changes. So then we can how much the concentration is present. So we can got the directly record. So there from this, I'm just going to buy to everybody. Thank you very much. And this is my lab, nano lab, and University of Pannonia. And this Mihaly Poshify is our dean. He is. I'm thanking for giving a chance. And this is my all groups. And this is my address or email ID. If somebody interested to talk with me, if you contact with me or discuss with me about this work, any question or whatever want, please contact me and related to other research work. And again, I am very much thankful to organizer to give me opportunity for talking here. Bye.